Hello guys, my name is Abhijit Tam and today I'm gonna explain or I'm gonna take introduction to logic gates to you. So let's get started. So logic gates is the basic building blocks for digital circuits. So in electronics there are basically two kinds of circuits. There are digital circuits and there are analog circuits. Digital circuits means they work digitally. They have two values, that is 0 and 1. So the objectives of this chapter is to familiarize with digital computer system and to understand the basic building blocks of a digital computer system, which are logic gates. So as I told you, there are two kinds of systems or two kinds of circuits in electronics, that is analog and digital. Analog devices and systems process time varying signals that can take any value across a continuous range, and digital systems use digital circuits that process digital signals which can take one of two values that we call 0 and 1, or high or low. I'll explain that. That is, I think those who have taken science in PUC, that is plus 2, will know what digital and analog circuits are, but still I will explain it. So I'll draw a graph. So this is a graph. So this will be time. So as this value will be, this is, let's say, 1 second, this is 2 second, this is 3 second, this is 4 second, and so on. And this will be amplitude. Amplitude is the intensity of the signal or the voltage. So in electronics or in digital circuits, the common voltage value is 5 volts. That is, if you observe, most of the digital electronic circuits work on 5 volt. That is, if you look at your mobile charger, it will be rated at 5 volt, mostly at 2 amps. But modern mobile chargers which support fast charging do 9 volts, 12 volts, but that's an exceptional case. But commonly the voltage is 5 volt. So this will be plus 5 volt, this will be minus 5 volt, and this will be 0 volt. So in an analog circuit, so let me write analog. In an analog circuit, the signal will be like, it will vary from 0 to 5 volt in about a second. I'm just like saying a circuit of frequency of like 0.5 hertz. That will be like, it will complete a frequency in 2 seconds, or it will, I mean, is it 0.5 hertz? I don't know, or maybe 0.25 hertz. I'm not really good at maths. Yeah, you get the idea. Like, it varies from 0 to 5 volt in a span of 1 second. That's the point. The frequency is not really important here. It varies from 0 to 1 second in that is 0 to 5 volt in 1 second. That is, if you look at when at a half second, the value will be like 2.5 volts. So at a quarter of a second, it will be like 1.75 volts, and here it will be like 2.75 volts, and 2.75, yeah, and here it will be like 5 volts, something like that. Like, it varies with time. That's the point. In an analog circuit, the signal varies with time. The voltage can take any values, like from the maximum upper limit of 5 volt to 0 volt to minus 5 volt. It can take any values in a span of time. But in a digital circuit, let me draw another graph here. Same thing. This is time, and this is amplitude. Most of the science students will know what amplitude is. This is 5 volt, this is minus 5 volt, this is 0, 1 second, 2 second, 3 second, 4 second, and so on. So in digital circuit, the signal will be a square wave. That is, it doesn't vary with time. It instantly goes from 0 to 5 volt in an instant. It doesn't take time to change values. That is, from 0 it will be 0, and at 1 second it will rise to like plus 5 volt instantly. It doesn't take time, and it will carry on for 1 second, and it will drop to 2 second, and 2 second it will be 0 volt, and in 2 second it will go to minus 5 volt. It will go on, and at 3 second it comes back. So it's like a square wave. So this value is 1 and the lowest value is 0. That's the point. So I'm just taking plus 5 volt and minus 5 volt because that's what I took here. So that it's just because for reference that I took it like that. The actual difference will be like plus 5 volt and 0 volt, and here it will be like 2.5 volt, and here it will be like 0 volt, because the potential difference is actually 5 volts. Here the potential difference is actually 10 volts. You don't have to remember any of this. You just have to understand the concept that analog signal changes values, and it varies with time, and it can take any range of values. And in a digital circuit, the change happens at an instant, like at a second, at a snap. It changes from 0 to 1 instantly. It doesn't take time. And it goes from 1 to 0 also, like 1 to 0 instantly at a second. At that instant it goes from 1 to 0, like it happens at light speed. Actual transition takes at light speed, because that's the speed of electricity travels nearly at the speed of light. So I don't know if your physics teacher have told you that. It's a fun fact. Electricity travels at the speed of light, nearly at the speed of light, not exactly at the speed of light, like 99.9% the speed of light. So that's about analog and digital circuits. So let me just clear this. Like analog devices and systems process time varying signals that can take any value across a continuous range. Like it goes from 0, and then it goes to 1, goes to 0, 1, 0. It takes time. And in digital circuit it's like low, high, high, low, low, high. It doesn't have any other value in between. It just have two states, 0 and 1. That's it. That's all you have to remember. Analog signals like have time varying signals that can take any value across a continuous range, but digital circuits have only two states, 0 and 1. And mainly you have to remember this 0 and 1. Analog circuits is not important because we are not using analog circuits a lot. It's only used for like scientific applications. Mostly all of the things we use are in digital. So you have to really remember that digital circuits have two values, 0 and 1, and it has a square wave. You have to important that term. You have to remember that term, square wave. And digital computers represent the most common digital systems. Once analog systems that used it, like in earlier times the first computers were analog computers, but now we use digital systems because instead of like having loads of values, it is easy to process like 0 and ones and zeros. Like it's compact, it's easy to process. That's why we use digital circuits. And we use digital circuits for audio recording, phone system switching, automobile engine control. Like in automobile, in cars, in earlier days we have analog circuits, mechanical circuits, but nowadays we have something called EBD, that is OBD, that's onboard device. It's a computer. That is, all of our modern cars are controlled by a computer. That is the engine, the oxygen that goes into the engine, the carbon dioxide that comes out, everything is monitored and controlled with a computer. There is a computer in your car. Your car is not just an mechanical device, it's also an electrical digital device. And movie effects like VFX and things, they are all done digitally. Still and video cameras, everything is digital these days. There is nothing analog. There is literally nothing analog except some meters. And in digital logic elements we have gates. gates are the most important thing, like they are the building blocks of computer. And in digital devices or gates have one or more inputs and produce an output that is a function of the current input values. Like that is like, I'll explain gates in a moment. This statement means that in digital circuits the output value just depends on two input values or two or more input values. That's it. Like all inputs and outputs are in binary, that is inputs and outputs can only take two values, that is 0 and 1. There is no other values in between. And a gate is called a combinational circuit because the output only depends on the current input combination. Like that's a self-explanatory, I don't have to explain that. And digital circuits are created by using a number of connected gates, such as the output of a gate is connected to the input of one or more gates in such a way to achieve specific outputs for input values. Like a computer is actually a huge collection of logic gates. Like there are millions of logic gates connected, like outputs of one is connected to the input of another, and so on, so on, so on, so on, so on. And like that, if you enter a large value, it will go through many logic gates and it will display an output. It all happens with the help of logic gates. Like logic gates are the building blocks, so they build the computer. Like they are the basics of computers or digital circuits, so we live with the help of logic gates. That's something that can be said. So digital or logic design is concerned with the design of such circuits. Yeah, that's also self-explanatory, I don't have to explain that. This is like 10 slides long. I'll end it very soon. What are logic gates? I just said that they are building blocks of a digital circuit and they are used for data processing on the circuit, and it is controlled by using transistors. Like it's in olden days, there one transistor existed as a separate component, like there were individual transistors in a computer. Nowadays the transistors are like they are nano sized and they are combined together in an IC chip or a processor. Like they are like compact, and millions of transistors are combined together in to make logic gates and to fit inside a small, like what should I say, 1-inch sized processor. So that's what it is. And output depends on the logic gate, and the input output depends on the type of logic gate, like which type it is, and or not, nor, XOR. And the input is of one of two states, high or low, and output is also one of two states, that is high or low. There are no other states in logic circuit or in a digital circuit. There are no other states, there is just high or low. And there are three types of logic gates, basically, like just the basics. There are three types. There is an AND gate, there is an OR gate, there is an NOT gate. And for those who have studied computer in PUC or +2, they know that AND is an operation in C++, so in programming, and or NOT, their operations. AND means if two conditions or two or more conditions are true, the output is true. OR means if any of the conditions are true, the output is true. And in NOT means if input is true, output is false, or input is false, output is true. So these are also computer functions, that is programming basics. So if you learn logic gates, you will also be able to understand programming easily. That is also a thing. So as BSc or BCA cyber forensic students or BCA students, we need to learn programming in further semesters, so this will be important for us. So we need to understand what AND is, what OR is, what NOT is, and how it functions. And we just mugging it up and by hearting it doesn't help. And there's a truth table for every logic gate. So a truth table is a list that lists every possible combination of values, that is both inputs and outputs of every combination, like every possible combinations, and it shows the output. That is the truth table for a logic circuit. So there will be inputs and there will be outputs. If for an 2-input AND gate, there will be 2 inputs, and this is AND and this is OR. So we have 0 0 0, and for OR is also 0. For 0 1, OR is 1 and is 0. For 1 0, and is 0 or is 1, for 1 1 and is 1 or is 0. That's, I'll explain that later. So for summary, in this session we studied analog and digital circuits. I explained analog and digital systems very clearly to you, and I defined logic gates, I defined truth table, and I just stated 3 types of logic gates. So that's it for this video. I'll explain, there are like a few more PPTs, I'll explain that too, and that's it. And for references, I'll share this PPT and this is like computer system architecture by Prentice Hall of India, and there's a digital design and like 2 books. If you want to refer, you can refer that, but you basically won't need to do that, and I also explain the notes to you. So that's it guys, thank you. I hope you watched the entire video, but it will be helpful to you. Thank you.